Hello and welcome to Additive Insight, the original additive manufacturing podcast and your source for news, interviews and comment on the latest 3D printing and AM intelligence, brought to you by TCT Magazine. I'm your host Sam Davies and today I'm joined by Intrepid Automation CEO Ben Wynne. Intrepid Automation is a vertically integrated additive manufacturing solutions provider which harnesses a proprietary digital light processing technology to produce digital casting tools. The company serves a range of customers in markets like aerospace, defence and healthcare, supporting them with application development and production, and in some cases, deploying its proprietary tech within their facilities. As Wynne joins the Additive Insight podcast, he explains the company's business model, shares the key capabilities of Intrepid's modular DLP technology, and outlines why the company's focus is primarily on casting applications. We also discuss the reasons manufacturing companies might develop their own AM technology in-house and explore how Intrepid's offering might evolve moving forward. If you like what you hear, don't forget to subscribe wherever you get your podcasts. You can also head over to tctmagazine.com to subscribe to the TCT membership platform and receive more Additive Insight for our print and digital offerings. Ben, welcome to the Additive Insight podcast. Can you start by telling us about your background in additive manufacturing, from when you were introduced to the technology at HP through to your work at 3D Systems?
Sure, thanks for having me, Sam. So a little bit about myself. So I started off my career in HP Labs in the UK, working on new product development, and obviously that's a perfect place for additive to be used for prototyping devices and new product concepts for companies like HP. And like most of us that have been involved in this industry for a long time, from the first moment that we saw one of these things, it was tantamount to magic. And I've been hooked kind of ever since. So, HP introduced me to the kind of conventional use of the technology in prototyping. But I've really kind of made it my mission over the last 20 years to really try to drive the adoption of additive into more mainstream industrial manufacturing use cases. So that's a little bit about me. Yeah.
So started at HP, went to 3D Systems, and after leaving 3D Systems, you co-founded Intrepid Automation. So what was the motivation for setting up the company at that time, and what challenges were you looking to address?
Sure. So going back from before 3D Systems, I worked on a bunch of 3D printing, 3D scanning projects, product development, technology development at HP, which was really interesting. And then went and did the entrepreneur thing for the first time. Was the CTO of a startup called Weave Wearables that was 3D printing insoles for shoes. So that's where I really tried to apply industrial 3D printing, in this case selective laser sintering, to a mass production, mass customization kind of area. Let's try and take this out of prototyping and use it in production. Through doing that, through working at that startup, I bought over $1 million worth of industrial equipment, and really optimized how we integrated with it, the front end, the software, to try to create that continuous, high volume production kind of flow, and frankly realized that there was a lot of innovation needed. There was a lot of work needed to kind of get it into that kind of mainstream. That then led me to through a mentor and friend who I developed at HP, a gentleman called VMS Joshi, who ran the HP inkjet business. I was tasked as one of the early hires in San Diego to build the advanced R&D site for them. And develop some products like the Figure 4 line of products, really focusing on changing the way that products are developed from a product concept to more of a platform asset kind of approach, where you have technologies that are platform centric that you can then instantiate in a bunch of different ways, so that you could be a bit more nimble and develop products that meet customer specific needs. I had a really good time at 3D Systems, learned a lot. But after about a year of working there, decided that it was time to move on, and founded Intrepid with the express intent of solving those same issues that I learned at the footwear startup. How do we do things like scalability? How do we get price elasticity to be in line with conventional material sets? How do we bring automation in to remove labor from the equation? So that's really kind of the impetus that started us. And but unlike the install stuff that we did previously, our core focus has been like industrial, aerospace, defense, kind of foundational manufacturing methodologies.
And so, in terms of the core competencies and the expertise of the group that you're a part of now, how would you assess those? How would you kind of explain what those are?
Well, when we founded Intrepid, I did so with legitimately the most talented engineers I'd ever worked with across my career in anything from cloud software to electronics, embedded electronics design, industrial electronics design, mechanical engineering, projection knowledge, deep projection knowledge. When we were at HP, we developed custom DLP projectors for them for a number of products. And so I really pulled together, a founding team that had experience in manufacturing, had experience in developing conventional products, and brought all of that know-how across all of those domains to the table. So we bit off a lot when we started Intrepid: material development, industrial machine development and building, cloud software, embedded software, AI, and obviously chemistry for the materials themselves. So we've done a lot of work, bitten off a lot, but in so doing have created a really interesting kind of vertical integration that allows us to kind of do some really special things with our technology and systems. So it's been really fun.
Yeah, we'll talk about the vertical integration concept a little later. But in terms of the technology and I guess the systems that you have at your disposal, there's a portfolio that includes a development kit, Epic, and Range. So can you take us through each of those systems and explain kind of their capabilities and when they are most suitable to use?
Sure. So we have, our technology is photopolymer based stereolithography essentially, and it's DLP based, which a lot of people are familiar with the smaller machines that use DLP printers. So if you've used the Stratasys Origin machine or Carbon machine or whatever it may be, what we've really worked to do is to industrialize those kinds of platforms and build an ecosystem around it. So let's start with Epic. Epic is a fully automated production cell that has multiple print engines in it. These are membrane single projector systems that are designed to produce highly detailed, smaller parts completely automatically from the data coming in, the files coming in, tray handling, material delivery, automation, placing and picking trays from those printers, all the way through to the post-processing. So the intent is we wanted something that sat on the factory floor that could turn data into objects without any human interaction. The dev kit works hand in hand with that, in that if you're doing product development or you're doing application engineering, you don't want to risk your factory to do your testing of your builds. So the dev kit works hand in hand with the as a single printer. It's a single printer of the printers that are inside the Epic. So it allows you to kind of develop and validate your builds before you send it to the thing on the factory floor. On the other side, which is really kind of the exciting, kind of novel part of what Intrepid is doing, is around our multi-projection technology. So we have around 26 patents that broadly cover how to take one projector and add multiple projectors, into an area, stitch them together to create one seamless image. And so we have our VAT-based systems, which is the Range kind of family of products, where from the waist down, it's a vat of resin, kind of what you're familiar with, the Neo systems from 3D Systems, from Stratasys, or the Pro X800 and alike from 3D Systems that's been around for 20, 30 years now. But instead of a single point laser drawing around, drawing and tracing each layer's geometry, our multi-projection technology exposes an entire layer at once. And so Range has a pretty big build area of about 30 by 26 inches, and is comprised of 6 projectors. But the core technology that underpins that is very modular, and we can make different form factors, different sizes, different numbers of projectors really quite easily. So the claim to fame there is that in industrial applications where you need large complex parts, think casting, industrial applications, sand casting, that kind of stuff, but you need them fast, this gives you size and speed. Where conventional laser-based SLA, even if you have multiple lasers, just can't keep up with a single layer being printed at once. So that's kind of our portfolio, and then around that we wrap automation, robotics, and some fun software hooks and things like that. So.
Yeah, and then Mini Range is the next system in development. So you mentioned there that the Range platform is flexible in terms of the size and the form factor. So tell us about this machine. Obviously, we understand the technology. What's the kind of thinking behind this mini range concept, and how does that fit into the broader portfolio?
Yeah, I'd say mini range should be looked at in a very similar way to the dev kit. The dev kit, as the dev kit is to Epic, the mini range is something that you can use to kind of develop and validate smaller designs or parts of designs. It's a lower hanging fruit to be able to get into an ecosystem. But I think I can't talk too much about unreleased products, but I think if anything, going the other way is more interesting. If you look at aerospace and defense and the needs of those industries, propulsion systems, jet engines, all these kinds of things, going larger than range is something that there seems to be a lot of demand for, as people push for more additively produced, topology optimized, or larger castings, or more complex castings, or things like that. So I think if I say watch this space, it's going to be interesting what happens when it's not just a 30-inch kind of system, but you're getting up into the 65, 63-inch by 63-inch kind of size areas, with the same print speed because it's layer based. So you have kind of pretty much twice the build area in XY, but the same print rate in Z. Making it even faster and even more applicable to mass production use cases. So, we're still a relatively, young company compared to the big guys out there, but we're very, very innovative, and we move very quickly and can develop products very, very quickly. So, yeah.
Yeah. In terms of the technology that powers all of these systems and platforms, how would you differentiate what Intrepid has at its disposal compared to other resin-based additive technologies out there? What have you developed that is different to other solutions that are available?
I think the core difference is the methodology by which we built our technology. I mean, people have tried to use multiple projectors and combine them together since a single projector systems were developed back in the day. What seems to have eluded people is that the way they solve these issues is that they try to add infinite mechanical adjustment to the projectors to get them to align, and then they use very experienced, very skillful, technicians and engineers to try to tweak and align these things together. I mean, that may work for a one-off lab prototype, but it's not a commercially viable product, because the maintenance and to keep those machines working when you need to replace a projector and things like that would be hugely burdensome. So what Intrepid did is we took a software-centric approach, where the projectors are fixed. They do not have infinite adjustment, XYZ pitch roll and yaw. Instead, we use sensors that are built into the system and smart algorithms and software to calibrate and combine all of these projectors together into one seamless image. So where other people may use a mechanical approach, we use a software approach, and that gives us a lot of flexibility, not only in producing new products, but makes something that in the field can be maintained, and the projectors can be replaced, and it will calibrate itself, and I don't need to send service technicians to Japan or to Europe or to wherever. It's something that is 2 screws, 2 cables, and a button, and the customers can do that themselves. So having used industrial machines and run industrial machines myself, even things like the support model behind the scenes of how they work with customers, I believe needs to change. So yeah, that's why we've done it that way.
In terms of how you work with customers, so obviously vertically integrated, I guess the focus is on parts in terms of the business model rather than selling the technology and the machines. What does a typical partnership with a customer look like?
It's interesting you say that. My business model is to deploy and support the deployment of hardware. That's the ultimate aim. But we kind of have it a little bit backwards compared to kind of at least my experience in additive, which is, instead of telling someone, yes, the machine can do everything that you want, buy it and it'll do it. And then we'll print your parts and blah, 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 and we'll work with you. We do it the other way around, where we show them that our technology can do what they need before we talk about machine sales. So we like to show that we can, our technology meets the need, that we provide, analysis. But back to your question, the way we engage with the customer is the first thing we say is, what do you need? What are your problems? We don't start with what machine do you want to buy? We want to understand what needs they have, where they've had issues before. And then, we can go down a couple of different paths. We can do manufacturing for them. We can drive that as a phase 2 towards deploying either the assets that meet their needs in their factories and support them in that, all the way through to building factories with customers as kind of joint ventures, or developing custom printers that meet their specific needs. So we try to, for us, it's not about having thousands of customers. It's about having the right large industrial customers in the right industries.
Okay, so can you quickly explain in terms of the, at a point where the customer and the application is ready for a deployment of these machines externally from Intrepid, how does that kind of handover and transition work?
So it's really quite simple. So if I take one example, there's a casting application that we're working on with a particular customer that makes a very specific type of geometry. The tooling for that geometry, of which there's a bunch of different SKUs for it, the tooling has become is normally quite expensive and takes a while to source. But over the last couple of years, the lead times and costs have increased further, to the point where it's becoming a real issue to how they develop their products. I mean, if say you work for a business where every year you're releasing a new set of products to keep people interested, but your tooling cycle is a year. That means that your development cycle is longer than your product lifespan. So trying to use technology to enable these businesses to kind of get ahead of that is that's the way we speak. But where it starts is we look at how they're conventionally manufacturing their parts. We then come up with suggestions and collaborate on how our technology could be used to create digital equivalents of that. So instead of making an injection mold to make a tool to make a pattern for casting, instead we digitally produce those patterns. We provide samples to the customer. They scrutinize them dimensionally. They put them through their foundries and produce metal parts with them. At the same time, we produce an entire unit economic model on how much it would cost to make these parts if they did own the equipment and run them in their factories. And then we kind of pull that all together into a proposal that we almost help pitch internally, with them to executives, and then execute on afterwards. So that it's a very high touch experience. It's not just please buy our stuff. We see our customers, especially if they're in the big industrial and have a need. It's a collaboration, it's a partnership, and it's one where the job doesn't start once the machine is sold. The work starts once the machine is sold, not selling the machine being the endpoint. So for us, if a deployment has to be utilized, the machine is designed to run. And we have customers that run their machines 24/7, 365. And those are the types of customers we love, because we're building capability together. They're getting new products to market faster. They're developing their products without having to wait for that tooling or that upfront capital investment. And it's great for us because we're selling more machines and we're seeing our technology kind of proliferate itself across different industries. So it's a high touch experience. It's not a numbers game, it's a quality game.
Yeah. You touched on a casting application there. And I understand that's a pretty big focus of the business. And obviously you'll be aware, with your background in AM, that it feels like the industry a lot of the time is focused on the kind of end use part, and we maybe forget a little bit about the opportunities in casting and those kinds of applications. So can you kind of explain from your perspective what you see as the big opportunity in casting applications for this technology?
Yeah, I think you touched on a really good point. My focus is sacrificial parts. My focus is parts that get used to make other parts. And the real reason for that is over the last decade or more, we've gone down the path multiple times of saying, here's a new 3D printing technology. It can print this type of aluminum or this type of material or this type of plastic or whatever it may be, a polymer. And then everyone starts comparing it against, castings or forgings for metal parts and commodity injection molded parts for other things. And quite frankly, there's a lot of work still to be done on the materials side to make slot-in replacements for all the commodity materials that we've developed over the last 100 years plus, right? Like nylon versus nylon. I mean, that's why like Modular Fusion and SLS and stuff like that are cool, because you want nylon 12, you get nylon 12. But in these areas where you want a particular elastomer or you want a particular thermoplastic or whatever, the materials not only don't necessarily meet the need, there isn't from a regulatory perspective the history of like, do these cause harm? if you were to print a watch strap out of a resin from someone in 20 years, are you going to get sick? Is that going to have caused sensitivity to acrylates, methacrylates, whatever it may be, versus just commodity silicones that are used today? So I think even if you can do something, there may be challenges, regulatory, safety, or even just price, right? We're not making enough of these materials compared to nylon or compared to this for the price to be in line with them. So what I've really focused on, what Intrepid really focuses on, is using our technology to help make other things better. We're not doing that in isolation. I mean, we've seen hero use cases for 3D printing in industrial high volume production of things like Invisalign, where you're printing a mold that gets thermoformed over and the mold gets thrown away. Again, it's a sacrificial part where you're using the fact that additive can make custom shapes, and then you're getting around the material, if there are any material deficiencies, by using a conventional, manufacturing methodology to do it. And I think when we look at casting, investment casting, sand casting, and other types of molding, I think it's a really untapped resource, because everyone has been focusing so much on that end use part. Because that's where the money is, that's where the sexiness is, and so it's really compelling when you say, we don't need this anymore because I can just print it. The numbers are huge. The everyone can see going and buying shoes or whatever it may be, but a couple of million pairs of 3D printed shoes being sold a year versus billions of shoes being sold that are made conventionally. Making tooling for those applications seems a lot more like an interesting way to apply at least our technology. So I think over time the material sets will get better. And the cool thing is that the fundamental technology can just print those and use those. But up until that point, we want to make sure that we're enabling the industrial base. So metal printing versus casting. I mean, most of the parts that are used in supply chains today, aerospace, defense, automotive, you name it, are castings of some sort. The supply chain's understood, the regulatory is well understood. All I'm doing is making a shape using 3D printing that helps make those better and faster. So that's kind of my hill to die on. That's what I'm really passionate about. And it's been really cool to see how our technology has been adopted by some of these industries over the years.
Yeah. In terms of applications, I wanted to ask a question in two parts, really. The first is, are you able to share any kind of real world application success stories? And the second is the kind of trends you're seeing in terms of the requests that you are getting from some of your customers. What kind of applications are they asking you about to gauge whether they're possible?
I can't be too specific, but I think if you look at kind of in aerospace and defense, things like propulsion systems, as more propulsion assets are needed, as they need to ramp up the production of those, faster digital casting solutions so that they can make metal parts with incredibly complex geometry, where they're taking essentially an assembly of multiple parts and combining them into one complex casting, is really where this stuff kind of shines. So if you look at the trends of what what products are being developed, what needs there are in those industries, it does start to get into the space of simplification through adding complexity to the geometry. I think what's really exciting as well is when you look at things like UAVs and some of these kind of more newer markets and interceptor drones and stuff like that, is being able to scale the production of additively produced interceptor drones and things like that for defense is something that we see an awful lot of power in, and uniquely, that's one of these areas where it's not a part to make a part. Those are final end use parts. So we have some very exciting collaborations with some drone and UAV companies, where one of our printers can produce 22 full drones in 8 hours per print. And so we're really starting to talk about not needing to fill a warehouse with thousands of cheap machines and then labor and all this kind of stuff to maintain them, but you're talking about getting that kind of manufacturing density that kind of normal manufacturing is used to out of kind of a certain square foot. So we see that there's a lot of need to move quickly. And as I mentioned before, with this one customer, the tooling cost and the lead time for tooling is becoming one of the biggest challenges to their business. So without, can't name names, but I think most conventionally made things use tools of some sort. And so for us to be helping to eliminate that lead time and upfront capital investment in a bunch of different industries to make parts that they normally make is a really exciting area of growth.
In terms of the decision to stand up the business with a proprietary technology, rather than just buying existing systems. I appreciate there's an element of your business that is deploying the technology, but in the sense of making the parts and focusing on that element, you could have just bought existing technology off the shelf and stood up the business that way. What was the economic considerations that you were making when you came to that decision in the early days of the company?
Fundamentally, the machines aren't good enough. There was nothing on the market that, from a reliability, quality, speed, and total cost of ownership, met the needs. I mean, in my previous startup, I bought, as I said, $1 million worth of SLS machines. One of the machines worked fine. The second one was a lemon. And I had to keep getting the engineering tech back to try to fix it. And then I got a $50,000 bill at the end of it for maintenance services. It's not. If there was the kinds of platforms that we've developed available, when we started the company, we would have leveraged them, wrapped our software and our automation around it. But it is unfortunate that there wasn't anything good enough and so we really had to step up the consistency, the quality, and the speed in order to unlock some of this stuff, right? Like, a lot of people have tried to just buy a load of conventional printers and put them in a room and say, I'm a new manufacturing, powerhouse. But it needs to be a bigger step function than that. And so that's that. As hard as it was to do, we did, and we're it's been nearly 8 years now. But we're really excited with the portfolio of technologies that we're sitting on, and we've got some deployments, as far afield as Japan, some foundries there, and it's really exciting to kind of see the adoption. What we are seeing is this technology can keep up with the injection molding approaches. And so some of these foundries, for example, are replacing what's known as a wax room, where they do all their wax injection and assembly. They're replacing that room with Intrepid's assets instead. And that's very exciting to see.
Okay, because it's a bit of a trend, certainly on the metal side, of these companies. So Divergent, Freeform, Vulcan Forms, Sura, Norsk maybe are starting to do it a little bit the same way that you're doing it, where I think there's a deployment now of Airbus in the works, but they're developing the technology themselves rather than procuring from the market. I appreciate it's a different technology and it's a different, it's slightly different business models. But can you kind of help us get in the headspace of why those companies are deciding to do that, maybe, and the risks and the challenges involved in taking that approach? Because it probably would be easier to just procure from the market. There's a lot of investment that needs to go into develop your own technology and a lot of time. So weigh up the kind of pros and cons of going with those approaches.
Yeah, I'd say I see what's happening right now in this way as a litmus test for whether the existing solution providers were meeting customer needs. And I would say that this is showing us that it wasn't, and it hasn't been. I think there has been a rift between hardware providers and the actual customers that use them, and I think people have been burned over a long period of time, and I think that like the free flow of communication requirements backwards and forwards between those companies to create a solution that benefits both companies is a very hard reality for some of these customers to have. As I say, the old experience is buy a machine, yes, it can do everything that you want, right? And then you buy the machine, you try to get it to do what you want, and it may not meet your needs. Well, then you've kind of poisoned the well, right? And then you don't buy the second machine because the first one didn't meet your needs. And what's interesting is when you look at companies like Divergent, they're a heavy user of the technology, right? So, I mean, they've realized that they understand their own needs better than they can communicate them to a third party. And so in some ways, especially when you're trying to get those changes to happen from an existing company, but they're not engaging with you, it's easier to do it yourself. Because at least you're going to be fulfilling your own requirements. And though I love that the 3D printing in the prototyping space is highly generic, right? And it's enabled it can be used for a lot of different things. We've all seen like diversity of the videos of various things that people have made and shown online over the years. But when it comes to like someone like Divergent, they know what products they're making, they know who they're making them for, and for them it's about owning and controlling the value chain so that they can deliver, to what the DOW or DoD needs, long term. So it's interesting that large customers of 3D printing technology over a long period of time have become 3D printer companies themselves. So I think even companies like AlignTech that have been one of the biggest users of third parties technologies over the years, ended up buying a 3D printing startup and becoming a 3D printing company themselves. So I think it's not about the technology, it's about the applications. And so these companies that own an application, making a machine is relatively easy, to build on top of that once you own your own market and the product you're making, and you can DFAM that product for the technology that you own or develop. So it's an exciting shift, but it's an important shift. We're seeing customers of 3D printing becoming 3D printer companies themselves to meet their needs.
I wanted to touch on AI. You've touched on it a little bit throughout, but obviously we've just focused on the kind of printing today, and you've mentioned that there's robotics and automation and AI that all goes and wraps around it. So with AI in particular, how are you using it, and how have you integrated that technology into what you're doing over the last few years?
Great question. So I think think of it like an onion with layers, right? Like they get bigger. Is the most basic level, we use AI for what AI used to be used for, which was monitoring and taking information, data, and trying to make sense of it, right? For things like print process, right? So our systems are full of sensors, and those sensors almost become a fingerprint for what was happening when a certain part was created. That's very important from a regulatory perspective. And so, we use AI to monitor and close the loop on the print process to make sure that we're getting good parts. But then as you kind of go up all the way up into the cloud, and then you look at the data, then you look at fleet management, then you look at physical AI to service machines and things like that. We're really kind of looking at all of that spectrum. So the onion keeps getting bigger, the layers keep getting bigger. I think what's really, really interesting is, agentic systems, how the factory of the future would be run, how different processes integrate and work together, with AI and robotics and things like that. So, we're focusing on the full stack is kind of what I would probably say, but very excited to kind of see where things go. And I think outside of the R&D space or the prototyping space, when you start talking about running a fleet of machines, you could think bipedal robots, you could think AGVs, you could think, handing off the printing to secondary and tertiary operations. I mean, making a product is not just about printing a part. And so I think what you're seeing from the companies we mentioned previously that are kind of making that shift to make machines is they're focusing on the application. They're focused on producing products and not printers. We're kind of working closely with our customers to do the same thing. We want a solution with them to change how their business leverages these technologies. And when it comes to casting, what's really exciting is that we've got hundreds of years equivalent of experience and infrastructure and billions of dollars of infrastructure in the US when it comes to things like foundries, and unfortunately, there's a real chance that some of this know-how could die out because there just isn't the people entering that workforce again. So adding digital to the front end of existing casting infrastructure will create net new capacity with net new capabilities that the Department of War and things like that really, really need. Going forward, without us having to say, I need to buy, 100, $5 million metal printers. I can literally bolt my technology onto the front of existing infrastructure and produce net new capability. That's exciting to me, like reinvigorating, catalyzing what we've as a country invested in over generations. That's exciting to me.
In terms of the evolution of the technologies you work with, whether it be the hardware or the software, where are you kind of focusing in terms of as you look to continuously improve the product and the offering? What are the next challenges that you need to address? What are the next improvements that you need to make within your technology stack?
That's a good question. I think we continually improve our platforms, both from a hardware and a software perspective. But when you're in a manufacturing kind of world, it's very resistant to movement. And so once you have a solution that works and that solution is documented to make a certain part for a tank or a plane or a rocket or whatever it may be, there isn't necessarily this same need to weekly improve. The release process for improvements will be much more well thought out and rolled out in parallel with the existing one and then switched over at a later date. I mean, the risk to make one change in software that changes the print process that then changes the part in additive is really true. So a lot of the power of additive, its flexibility, can also be its undoing when used in highly regulated processes. So we always aspire to make the technology better. And I think there's a lot of space to do improvement on the material side. I think there's also a lot of space on the machine side to continue to push the boundaries of speed and quality. And for us, that means higher power, higher resolution projectors. And we also have some other kind of technology in development that we've patented that could be an interesting follow-on to that. So I'm an innovator first and foremost. I started off in HP Labs doing deep R&D. I think the second you stop doing R&D and trying to improve what you have is the beginning of the end. And so I aspire to always, and I try and create a culture inside the company where keep inventing, keep doing it. I mean, it would, I suppose it's the best scenario is that you develop a technology that makes your existing technology irrelevant, because if you don't do it, one of your competitors will. Mm-hmm. So, I like, why should anything stay still? I think from a customer and manufacturing perspective, there's regulatory concerns to like keep things stable. But inside Intrepid, let's push the boundaries. Let's keep going. I mean, that's why making, the system that we have right now, I think is the biggest and fastest resin printer on the planet. But, as you look forward from, 30 inches to 62 inches and beyond, it starts to get really exciting, especially when you look at some of the use cases behind that size need as well.
Yeah. So with all of that in mind, and I'll make this my last question, Ben. So thank you for taking the time today. How would you kind of describe your vision for Intrepid Automation moving forward?
Getting lots more machines out there and in new parts of the world. But I think really it's about creating a resilience and an independence from kind of some of the supply chain challenges that we've faced over the last couple of years. I mean, we've all been through them. When we look at things like tariffs, when we look at things like lead times, we look at geopolitical uncertainty. For America to be able to rapidly produce the things it needs without having to wait for tooling to arrive from another country, or things like that is paramount. And so going back to the digitizing existing foundry infrastructure, Intrepid is about creating jobs. Intrepid is about creating saving some of this know-how that's in the US before it dies out, frankly. Metal printing and other things are great for certain use cases, but there's an awful lot of other parts that get made every single day that this technology can help. So my hope is that we can stop some of these foundational skill sets and competences in this country from dying out, while adding new capability at the same time. So fundamentally, I want to solve customers' problems, and I want to help make additive a real foundation for mass manufacturing instead of what is still quite a niche technology set.